let's do this in 2 videos. Okay, first we're going to do life, and then we'll do death. As far as life cycles, it's not biologically alive, obviously, but so we talk about its birth to its death, and you know about its birth, but let's go through this. So the idea, keep it fairly simple. Obviously, it can get very technical, but in each fusion cycle or life cycle, it's in hydrostatic equilibrium. I know the other one got cut out. I'm trying to do better here. So here's the picture. What does that mean? So gravity will pull the gas in, right? That'll start fusion, and that fusion will create light and that heat, and it'll push the hot gas, and the light will push the gas back out until it reaches hydrostatic equilibrium. That is, the inward pull of gravity is balanced by the outward push from light and gas, the convection, etc. When gravity wins, this is important, when gravity wins, it's just a tug of war, then it'll collapse. When light and gas win, it'll push out and expand. Okay? So here's the idea. Let's see how we're doing on our videography here. All right, maybe I'll zoom in a little bit and I'll come back, make sure I do that. Let's go there. All right. So, basic idea. Gas collapses, right? And then it starts the first fusion cycle, which you know what that is, right? Main sequence, etc. We'll go over that again. Okay, so gas is collapsing. Then it starts that fusion cycle. It creates light, heats things up and pushes it out, expands until hydrostatic equilibrium. In is balanced by out. And it'll do that through the whole cycle, so it'll go through this cycle. But when it's done, no more fusion, stop slow fusion, then the outward pushes no longer, or not as much. Gravity's going to win, and the star will collapse. But that's going to squeeze the next simplest cycle. So gravity wins until it starts a new fusion cycle. The new fusion cycle is going to push out, expand. When the fusion cycle starts, you start creating that light, that heat, the hot gas, the convection pushes out until it's in hydrostatic equilibrium for that cycle. So you squeeze in to start a cycle. When you start, you'll expand to hydrostatic equilibrium, or gravitational equilibrium, if you want to call it that. Then when it's done, it's going to collapse, start a new cycle, expand back out to a new hydrostatic equilibrium. When that fusion stops, the star collapses, new fusion cycle starts, expands to new hydrostatic equilibrium, go through the cycle. Go through all that fusion that you can in that layer. Repeat until there's not enough gas, so not enough mass, so not enough gravity to fuse anymore, and that is what we call, I did it, didn't I? There it is. Sorry. That is what we call star death. Okay? That's it. Okay. No fusion, gravity's going to win. Fusion starts, it's going to push out, but only until it gets to balance. Then it'll go through the whole cycle. Cycle stops, collapse, start a new cycle, expand, balance. Finish the cycle, collapse, expand, balance. Go through the cycle, finish the cycle, collapse, expand, balance. Until it can't anymore. That's the next video. This one will be short. Okay, so what happens next? How's this going to go? Well, let's do a quick review here. Rolling cart. Okay. So, gotta go all the way up there. Let's do that. the temperature and luminosity we saw in the HR diagram in the discussion before, that it depends on how much gas a star starts with. So you can start with a lot of gas or less gas, and you saw that there's a range of stars that start with different amounts of gas. But all stars start as main sequence stars, which is fusing 4 hydrogen to 1 helium in the center, called the core. Sometimes people get confused though when you say core because they think of Earth's core. No, the center we call the core, but it's all gas, right? Key. How much mass the star has, again, determines where, that is the temperature and luminosity, on the HR diagram. So it might be up in those blue-white stars, it might be in the white stars, down in the yellow stars, or in the red-orange stars, right? But they're still doing the same thing, and the difference is how much mass, right? Because we got more gas, you got more mass, you got more mass, you got more gravity, you got more squeeze, and the rate at which the fusion goes on changes. Okay, cool. Now, this might be interesting. I mean, think about that HR diagram, right? You can visualize it, right? You got the luminosity and the temperature. The main sequence goes up like that. But we had those funny ones, right? What? How come we had it cool and high luminosity? Cool, so red. The only way we could explain it being so luminous is that it had to have a big surface area, so they're red giants. What's up with those? I mean, what happened? And then what about these ones down here? Remember those ones down here? The ones that were hot, so white hot, but not very luminous. The only way that something white hot's not going to be very luminous is that it's got to be small, smaller surface area. White dwarfs. What's up with that? And then there were the supergiants. So our sun is now a main sequence star. Most of its life it'll be a main sequence star, but it will turn into a red giant. Once stars are done being on that main sequence, all of them start there, but once they're done, they will change. They will go through these processes, and the temperature and the luminosity of the star will change. And so, here's the second phase. You're done. Now the center, or the core, is all helium. For all stars do this, right? It's all helium. You got a big old helium balloon. Yay, party. What's going to happen? Uh-oh, fusion cycle's done, right? Creating balloons. Fusion cycle's done. Let's push out. What happens? Collapse. Star fusing. It'll fuse the next easiest fusion cycle. What's the next easiest thing to do? Well, the next easiest thing is 4 hydrogen to 1 helium. You go, wait a minute, but not in the center. The center's helium. The next easiest is in a shell around the core. A shell around the core. So we got a helium core center, gas, and around it we've got 4 hydrogen to 1 helium. 4 hydrogen to 1 helium, right? Around there. As it does this though, right, it collapses, it starts the fusion cycle, that expands. When a gas expands, it cools. And so collapses, starts this fusion going. When that fusion goes, it expands until it's in hydrostatic equilibrium. But when it expands, it really expands, and it expands to a giant. So here it is before, and then it collapses and goes, and then it's here. And it's a giant. But as it expands, it cools. I use K because cool man, KM stars, right? And cools to red, right? Red is cooler. Red giant. That's what happens. In fact, it goes through this. I did it again, didn't I? Just, oh, no. There, that's going. Okay, good. Doggone it. There. Follow me now. Okay, good. All right. cores all helium. When you're done with the first phase, collapses, starts fusion of 4 hydrogen to 1 helium around the center in the core. It expands when that starts until it's in balance. But when that expands and when it starts fusing, and then it starts doing this, the star expands to a giant from here to here. And as it expands, it cools to red. Cools to red. A red giant. And then when it's done with that, it goes through this cycle and the next fusion cycle, the next easiest fusion cycle, much faster than the first one. Most of its life is spent doing the first one. All of them mostly on that main sequence line in the HR diagram. But they will go through cycles. And then there are other cycles. And let me just say this. Oftentimes, and generally there's going to be fusion at different layers, different fusions going on at different layers, and that's some complicated physics and so on. But so you get this idea though of collapse, expand. But in that cycle here, when it expands, it'll cool, expand to a giant, be cool to a red. That's where the red giants. Everybody started on the main sequence, but now that it's a big old helium balloon, we got this going, making more helium balloons. But other things are made too. We're going to talk about that on the next one, and we're going to talk about when the star can't fuse anymore. Okay? So there are multiple layers. You can look that up if you're interested. Easy to find, but I don't want to overwhelm any more than already. Okay, so you've got this idea, I hope. Keep it simple. Collapse to start fusion, expand, balance. Done with that cycle, collapse, start fusion, expand, balance. Keep going. And the fusion cycles, again, can be in layers, and that can be of interest. Okay, let's see what happens. Let's see what the stars can do.